Hello everyone. In this video I'd like to go over an example of how to find limits numerically. Uh, I'd like to point out that there are three ways of finding limits. You can use the numerical method, in which uh, you find the left and right limits by plugging numbers into Excel or calculator. But because we use Excel in this class, let's stick with Excel. So you plug in numbers in Excel and you actually compute the outputs, the f of x's, in order to check whether the three conditions for the existence of the limit are met. So what that means is, let's take a look back at the definition of a limit. The limit of a given function f of x as x approaches value b exists if three conditions are met. The left limit exists, meaning as your value x approaches the value of interest b from the left, that limit, there's a clear convergence towards a fixed value, so that means that the left limit exists. Secondly, the right limit must exist, and these two limits must be equal to each other in order for the limit to exist. So here I have an example in which my goal is to find the limit of this function x minus 3 over x squared minus 9 as x approaches 0. So here we're working within the neighborhood of x equals 3. So how do we make it happen? So let's say 3 is our value of interest. How will we approach 3 from the left or from below? So the closest value to 3 decimal places will be 2.999. If we step one step further to the left, it will be 2.99. And if we step one step further again to 3 decimal places, as we step towards the left of 3, we will be at 2.9. So the idea again is, as x grows towards the value 3 from below or the left, what is the corresponding behavior for the function of interest f of x? So what we need to do here is evaluate f of x for the corresponding x values. So what I make sure to do is plug in for my function f of x formula, my function f of x's formula, which is input minus 3 wrapped up between parentheses over input squared minus 9, of course wrapped up between parentheses. So that's my f of 2.9, and I make sure to evaluate the other f of x's. And here you should be able to tell that our value seems to be growing towards the value 0.17 from the left. What happens at 3 is not relevant to the existence of the limit. F of 3 does not exist because 3 does not belong to the domain of this fraction. As you've learned in pre-calculus algebra, if you plug in 3 here, you get 9 minus 9, and you can't divide by 0. Therefore, Excel will throw you this warning, can't divide by 0. But that's okay. It does not impact the existence or not of our limit. Now we've approached 3 from the left, and we can see a clear convergence towards the value 0.1, about 0.17 to 2 decimal places. Now let's take a look at how we go about approaching 3 from above or the right. Let's stick to 3 decimal places. The closest value will be 3.001. The next one will be 3.010. The next one will be 3.1. And again, we are stepping away from 3, or we are stepping closer to 3 from the larger end, the larger side. So we copy the formula across in order to get the corresponding outputs, and it's clear this time again that there seems to be a convergence towards the value 0.17. So as x decreases towards the value 3, or as x approaches 3 from above, f of x, the corresponding f of x's, the output seem to be increasing towards the value 0.17. So at this point, we are ready to conclude that the left limit of f of x as x approaches 3 from the left, again we write here, was 0.17. So that limit existed and was equal to 0.17. Similarly, as x approached 3 from above, again we were here on the right hand side from the right, f of x approached the value 0.17. Therefore, the limit exists. So we write that the limit of f of x as x approaches 3 without any sign this time exists and is equal to that value we had for the left and right limits. Again, it has to be the same value, so both limits must exist, and on top of that they must be equal to each other in order for the limit to exist. So that's how we take care of limits numerically. See you on the next video.